Good morning to all of you. I am Surya Chandan Sahu, PTGF in Electrical Department, Bose, Cuttack. So, previous class we have discussed about LT line installation. So, LT line installation is for around 440 volt to 11 kV, but above 11 kV the installation is known as HT installation. So, we will discuss HT installation by solving a problem. Suppose the problem is like this: an overhead 11 kV 50 Hz line has to be erected using 27 kg 10 meter long. That means the steel pole has a length of 10 meter long and ACSR conductor hub, the specification is given 6 by 1 into 2.59 mm with an average span of 150 meter. Already I have discussed in the previous class, span is the between two consecutive poles. So, here the average span is 150 meter. So, we have to make a list of material required for the estimation of the HT line installation and its cost. So, given the length of the 11 kV line is 1 kilometer, average span is 150 meter and the number of span will be 1000 by 150. Already I have discussed in the previous class, the span is equals to 1000 divided number of span. This is your number of span is equals to 1000 divided by 1 span. It is around coming 7, say it is coming 7. Therefore, number of 27 kg 10 meter long poles required is number of poles required is equals to number of span plus 1. So, number of span is 7 plus 1, that is equals to 8. So, here number of span is 8, number of long rail poles required is 8. Next, we have to find out the next important material, that is length of 6 by 1 into 2.59 mm ACSR conductor required is 3 times the length of the line plus 2% sag. So, 3 times because for R, Y, B 3 phases, that is 3 into 1000, the total length of the line is 1000 and 2% sag plus 2% sag means 102 by 100 into 102 by 100, it will come 3060 meter. Next, length of the GI wire as earthware. Earthware specification is 8 SWG. What is SWG? Standard wire gauge. So, this 8 SWG is the standard of earth. It is the standard of earthware. Then length of earthware will be, total length is 1000. So, 1000 So 1000 into 102 by 100, that is 2% sag. It will come 1020 meters is required the earthware. Next we will move to the material list. So rail pole, already we have discussed 8 numbers of rail poles are required. 8 numbers of rail poles and 6 by 1 into 2.59 mm. That means 6 by 1 means central conductor, and around this we will have 6 conductors, 1, 2, 3, 4, 5, 6, 6 conductors. This is your 6 by 1, 6 by 1 SCSR conductor, and 2.5 mm, each diameter is 2.59 mm, each diameter, each has 2.59 mm diameter. So this is the standard of SCSR conductor, and it is required 3060 meters, and the cost varies from company to company and some time to time. For the timing it is given 65 rupees per meter, and we are requiring total for 3060 meters, it is around 2,01,600 rupees. Next, this is the what the different types of rail poles required, that is from one cross arm to another cross arm the minimum distance is 1.5 meter, and from the bottom cross arm to the ground floor is 7.5 meter around. For L type cross arm, for T cross arm it is between two consecutive cross arms, it is 0.8 meter, and total height around 10 meter. Next, GI earthware, already we have discussed, that is 8 SWG earthware, 1020 meters is required. Then cross arm required is total 6 numbers of cross arms are required, and each has a cost of 1500, so total 9000 approximately. Next, T-cut cross arm of 100 mm, 100 mm, 2.2 long, that is, suppose this is the cross arm. This cross arm has 2.2 mm long, that means from this point to this point this is 2.2 meter long, and its diameter is 100 mm into 100 mm, 100 mm into 100 mm. It is required for H pole structure, that is double pole structure. It is required for double pole structure. So for two double pole, that is one dead end and another is the tapping point. So its specification is 2.2 mm long and diameter is, or the thickness is 100 mm into 100 mm, 100 mm into 100 mm. So next is this is the one cross arm, wood T-cut cross arm, one example of T-cut cross arm, and it is different types of arrangements of cross arm. Typical single pole design of distribution system for single arm, line arm and side arm. So next, this is another structure. This is the example of double pole structure. This is the example of DP structure, that is double pole. Example of double pole structure. DP stands for double pole structure. Next, top insulator brackets H pole structure is 6 quantities, earthware clamps 7 earthware clamps required. These are the examples of earth arms. Next, earthware clamps. Next, this is the example of Dix insulator, which is used in double pole structure or in the dead end. This is different types of earth clamps to fix the earthware. Next, this is the cross bracing required for H pole structure and 11 kV pin insulator required for the poles. For one pole, suppose required is, for one pole number of cross arms required is, for one pole the number of pin insulator, for one pole number of pin insulators required is equals to one pole number of pin insulators required is 3. So for 7 number of poles, so number of pin insulator required is 3 into 7, that is equal to 21 numbers of pin insulators required. 21 numbers of pin insulators required. Next, this is an example of cross bracing H pole structure. This is different types of disc insulator. Next, disc insulators required 6 numbers for 2 dead ends. For dead end, for dead end is equals to 3 numbers, and for tapping pole is equals to 3 numbers. So total is 6 numbers. Next, 14 SWG copper wire binding, that means to fix the different earthware conductor, some copper binding wire required. So that is suppose approximately 2.5 kg. This is the internal structure of 11 kV Dix insulator. This is the cross connected to cross arm. This is the insulator, and this is the socket or thimble to support the earthware. Then helical formed dead end. This is the helical formed dead end. Next, 14 SWG copper wire is used to fix the conductor insulators in the pole. Next, stay sets, that is, suppose each pole in HT line requires stay sets. So, total 7 number of poles, so it will require 7 sets of stay sets. Next, earthing set, 4 set completes required for 2 dead ends and 1 for intermediate and 2 intermediate poles. Total 4 numbers of earthing sets are required. This is the stay set arrangement, that is gay insulator. This is gay insulator. This is gay insulator which separates from top to bottom. This is the stay wire, and this is the stay bow to support the stay wire at the ground level. This is the stay rod and anchor plate inside the ground, and this is the pole clamp, and this is the pole. So, next, this is the transmission tower earthing. So, this is how the transmission tower is. This is one example of pipe earthing. This is one example of pipe earthing. Pipe earthing. This is example of pipe earthing. Next, 11 kV lightning arresters are also required at the dead ends, and danger plates 11 kV, written 11 kV danger plates, 7 numbers for each pole is required. So, this is the lightning arrestor structure. These lightning arresters are placed at the top. This is the lightning arrestor. 11 kV, or it is also called surge arrestor. It is because it suppresses the voltage surge due to lightning. Next, this is the 11 kV danger plate, written background white and written in red. Next, barbed wire 20 kg around required not to enter the unauthorized portion into the H pole structure. Then pole foundation mops, 8 numbers for each poles is required. This is the example of barbed wire. This is the pole foundation. This is the arrangement of pole foundation. Next, knee bracing sets, 6 numbers for each intermediate structure, and guards for supporting the H pole structure, 6 numbers required. This is the example of knee bracings sets. Knee bracings for intermediate poles, and this is the GSL number 4. The specification is GSL number 4 used as guards to support the GUARTS guards to support the structure, to support the HT pole. Next, CI rails to support continuous earth. That means for earth continuity, CI reels are required, and for each pole we require one CI reels. So 8 number of poles we require 8 CI reels. Next, MS channel iron angle, that is 2 numbers is required. This is the reel insulator or CI reel to support the earthware, and this is the guarding, that is guard system to support the CI reel earthware. This is an arrangement. Next, this is the MS channel, different structures of ML channel, flat bar, angle, round, different types, that is flat bar, angle, round, this is round structure, hexagon, sheet plate, channel, wide flange beam, standard I beam, square rectangular tube, pipe round, T bar, half round, half oval, chamfer bar, and rebar. These are the different types of MS channel required to support the H pole structure. Next, sundries to complete the job such as bolts, nuts, washers, thimbles, painting of iron parts, soldering, etc. Lump sum, around approximately lump sum required. Next, transportation charges, suppose 5% of the total cost, labor charges 10% of total cost, contingencies 1%, inspection fees. So total grand total suppose coming 4,44,000. So this is all about the